Hello. Let's install the TensorFlow. Meanwhile, we can discuss the um, 3D part. Okay. So basically, we are going to discuss about the introduction to the neural network. Okay. So what are neural network? A neural network is a machine learning model inspired by how the human brain works. So I think you are familiar with the words neural, neurons. Yeah, this is a biological term, but the how this neuron is working in our human's body, same way we can use a neural network in our this Python. So let's see. It's designed to recognize pattern, make decision, and learn from the data. It's widely used in a image recognition, speech recognition, natural language processing, financial prediction, etc. So this is the image of neurons. So these are the dendrite, and this is the place where some activity happen, and then they can do some sensor. They work like a sensor. So same way, we can give some input to our neural network, then they will process the data. After that, they give some output. Okay. All right. In simple terms, just like our brain has neurons connected together to process information, a neural network has artificial neurons nodes connected in a layer. Okay. These nodes take input, apply weight and function, and pass output forward. Gradually learn to make accurate prediction. See, this is the diagram of neural network. Is the Its working is just like neurons of a human brain. So let's suppose this is a structure. If we somebody give input one, then somebody give input two, then input three, it will go to the our neural network, and under this all the steps are connected with the another steps internally. So this part is called W1. This connection is called W1. Similarly, W2 like this. After that, they do some internal calculation. Hidden nodes layer call. This is called the hidden nodes. Here some calculation happen. After that, output node layer. So they will get output one and output two like this. So this is the diagram of neural network, how it's look like whenever we talk about the artificial intelligence. Okay, so neural network architecture. So first is input layer, already discussed input layer. So receive raw data like number, image or text. If we give something like text into the chat GPT, so we give some numbers or some text or some image. After that, chat GPT can process and then give some output. All right. So first step is receive raw data like number, image or text. So pixel value or image like this. After that, hidden layer. These are the parts where some calculation happen. So perform computation by combining input with weight and activation. Weight is nothing but this step. Weight 1, weight 2, weight 3. Uh, just hold on. Let me give 1 second. There is some noise behind me. No, give 1 second. Hey, hey, अभी बोलेगा चिल्लाएगा नहीं. Hello. यस हाँ बोलिए हाँ अभी होंगे जाइए ना हाँ है हाँ जाइए ना 1 घंटा 2 घंटा कोई ठीक नहीं आज बाहर जाने वाला है जल्दी जाइए बाहर जाने वाला है आज किसी काम से हेलो हेलो यस स्वप्निल okay so okay this is the diagram of neural network so input layer after that hidden layer so perform computation by combining input with weight and activation function so weight is nothing but whatever the this is the internal things this neural network will generate this value the w1 w2 these things after the more layer the deeper the network called the deep neural network okay so intermediate layer where the actual learning happen this intermediate layer is where the actual learning happen to our model of neural network so weight is important factor of input our network learn weight automatically during the training here whatever the network we generated the weight automatically during learn weight automatically during the training adjusting weight is what make the network smarter over the time so and the third layer is the output layer produce the final result like classifying an email spam or not okay so this is the formula output that is indicated by z and x1 the input given by us w1 is the weight mathematical part that is given by the generated by the our network plus x2 the second input w2 the second weight plus bias bias are the external factor which we use to make our system more perfect hello okay so this is the formula of entire this neural network so whenever some model neural by using neural network if they give some output so this way they can give the output x1 that is input w1 sorry this is the mathematical part which is self generated by this our neural network no we don't calculate this is some factor here see x1 x2 is the input value whatever we give w1 w2 is the weight and z is the weighted sum before activation function so if w1 is 0.9 and w2 is 0.1 so network is saying x1 is more important than x2 this way and bias is the extra adjustable value so whenever you see the example then you can understand a bias is an extra adjustable parameter added to the weighted sum of the input before applying the activation function. So it allows the model to shift output curve left or right, making the neurons more flexible in our learning. Why we use this bias and this activation function? Let's suppose we give some data to our model, artificial intelligence model. So whenever it's give the linearly, and so its result will be fixed because we use in our this model no here uh, here we use to predict the house price it gives the linear variable wait a minute not this not this yes this one in the last class we discussed about this we give the area and we give the price sorry this is also the example of the same roadmap So we discussed about the linear regression. Hope you remember. So in linear regression, we get the linear answer. So whenever we give some input like this, we give linear data to our model like this. Here, it's gone. Just a minute. House price prediction. No problem. So whenever we give size of the house, whatever we want to purchase, we give a fixed value. So same way, and that gives the linear answer. Linear answer. But in practical life, nothing is the linear. So that's why we add this bias as well as this factor activation functions, because so if we give some linear value, linear data to our system, it's give the linear answer. But in actual, no, nothing is the linear. There is different kind of data people are using. Not every time ideal data. No ideal data people are using. That's why we use this kind of our model. We give a bias as well as activation function. Let's understand with this example. So it allows model shift the output curve left and right, making the neurons more flexible in a learning. Effect of bias in a neuron. So this is a linear graph for linear regression. But when we add some bias and activation function, it will shift either left or right. So in practical life, the data is not ideal. In that case, it will help. Bias and activation function can help give the accurate data. Actually, yeah, practical data. It will give the practical answer. So blue line B, output pass through the origin, no flexibility. This is the linear line. But B2, the line shifted upward because of the bias. So when we add bias value, it will shift it. It becomes flexible. Let's see how to work step by step. So input value enter the network. Each connection has a weight. Importance of that input value. A neuron's computation. So output is activation function, input and weight plus bias. This is the formula of Z. And what is Z? Z is the output. This Z. Here, this Z. Yeah, this is the output. Whenever we give input, it multiplied by weight, and then uh, uh, do the summations of all the input and weight. After that, in addition, we plus the give the bias value like this. So after that, we have a activation function, and then input and weight plus bias. This is the basic formula. Okay, after that, data flow through the layers, adjusting weight during the training. Back propagation to reduce the error. So real life example, face recognition, unlock the phone, spam filtering, email classification, and stock prediction, forecast the price, then voice assistant, speech to text. By using this neural network, the voice assistant, it means speech is converted into text. Whenever we use this speaker in our phone and give some data to the Google, they convert speech to the text. So example, a teeny neural network predict or get. So let's suppose we are going to discuss this example. So whenever we give input 0 0, it will give output 0. Whenever we give input 0 1, it will give the output 1. Similarly, 1 0 1 and 1 1 it's 1. So we will make a neural network to learn this. See, this is our small program for neural network. This means the neural network learn or get. So let's copy this code. Yeah, I'm waiting. Yes. 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 So activation functions, we are going to use activation functions once we get the linear result from our model. Okay, an activation function decide whether a neuron should be activated, fire or not. It take the weight sum plus bias and transform it into the neuron's output. Okay, without activation function, a neural network would just behave like a simple linear equation, no matter how many layers are. Okay, that's why we are going to add this activation function. Otherwise, it's give always linear result. So yeah, so common activation functions are sigmoid function. First activation function is sigmoid function. Then 10H, that is hyperbolic tangent functions. After that, ReLU, rectified linear unit. Then fourth one is leaky ReLU, parametric. And then fifth one is softmax, combination of multiple sigmoid activation functions. So let's discuss one by one. So first is sigmoid activation function. So this is the formula of sigmoid activation function. Fz equal to 1 by 1 plus e to the power minus z. So z is the output of these things. Here, here, z, z, it means output. Here, z, yes. Okay, and let's first check with this OR gate example first, then we can discuss about the activation function. Okay, so we are going to just checking the OR gate, and this is the input and output. So yeah, so import NumPy as NP because this is a mathematical operation. That's why we import NumPy library. Then define sigmoid. We are going to use sigmoid activation function here. I told you no, so many activation functions. Sigmoid. This is a sigmoid activation. Here we use sigmoid. Return. Just check the formula. Return 1 by 1 plus here 1 by 1 plus u power z. Okay. Okay. After that, so input is 0 0 1 0 1 0 1 and 1 1. Output is 1 1 0 1 1 1. Can you give me 1 second? I have one call is coming. Hello. Call, call. हाँ 5 मिनट नहीं नहीं अभी रुक जाओ फोन करो. Okay. Hello. So we will give this input and this will the output will come, and this is the output result, and we add activation functions here. We add activation function because this is a linear result. If we use the activation function, it will make our model more accurate. So np.rand weight equal to np.rand this. So don't worry about this code because we are going to use ChatGPT to generate this code. We are not going to learn the manual coding because manual coding is not useful now. Hello. Okay. Yeah. So when I run this program, let's see. See, like this. A final weight is 6.180, like this. This is a final weight. W. I told you W. This is the final weight. Final bias. This is the bias value. And prediction is 0, 1, 1, 1, like this. This is a W value. W. And this is a bias value. And so we get the prediction is 0, 1, 1, 1. Yeah. Now let's discuss about some activation functions. So this is a first activation function is sigmoid. So fz equal to 1, 1 by 1 plus e to power z, and z is the whatever the output, linear output we get. So put the value of z into this formula, we will get a sigmoid value of z. So output will be shifted into 0, 1. First like a it's moved like a linear line, linearly. Okay, but when we add the sigmoid value, it will shift like this, curve like this. It will go from here and then from 0.5 and then it's go straight, it doesn't touch the 1. So its value is between 0 to 1. Okay, so output is between 0 to 1, good for probabilities. The problem is vanishing gradient, very small update for a large value. Okay, after that 10h hyperbolic tangent. So in this case, here no negative value, only positive, 0 to positive value. That is between 1, 0 to 1. But when we use 10h, it shifted, start from the minus value and then it will go to the positive value. So it fluctuates. Yeah, it fluctuates between minus to plus. So sometimes, let's suppose we have a, whenever our model trap the spam emails, so sometimes they trap some negative emails also. Sometimes they yeah, so that's why it's necessary to move our data between negative value to positive value, but not very large. It's between minus 1 to 1. So this is the formula for 10h. First case, it doesn't go into the negative value, but in real life we get the negative value. That's why we use this formula 10h hyperbolic tangent. So fz equal to 10h z and e to power z minus e to power minus z divided by e to power z plus e to power minus z, and the value of e is always these things, 2.71828. Okay, so output between minus 1 to 1, uh, centered at 0, better than sigmoid for the hidden layer. Okay, after that ReLU rectified linear unit. This the full form of ReLU function, activation function is rectified linear unit. So formula of this is fz equal to max 0 z. So if z, so z is greater than equal to 0, it will give the z value. If less than 0, it will give 0 value here. So z equal to 5, z equal to 0, z equal to negative. So whenever we use ReLU rectify activation function, it will give, if first output is 5, that ReLU activation function gives 5. If it is 0, it gives 0. If it is minus, it gives 0. Okay, in this case, if the case is negative, let's suppose the email is actually not a spam, but our model trap as a spam, so it gives the negative value, so it will count as a 0. So yeah, output 0. Hmm. Okay. So first of all, here see, we just simply develop a model which is based on the OR gate. Yes, Yeah, yeah, yeah. So, so we can use in our program. It will come whenever I. Hmm. Yes. Yeah. Yes. Hmm. Yeah, yeah, yeah. We need to customize. We can just yeah, develop our code from by using the chat GPT, and then we can customize it. It will automatically give, see this formula is given by chat GPT. Okay, so here we can customize it according to our need, according to our project or whatever we want as a result. It will, we can customize it, but we have to understand the logic, what logic they are using, what kind of logic using in our code. That's then we can implement our whatever we need as a result. We can edit it. Yeah, that's why we have to read about the theory. So these are the ReLU activation function, and it will give result between 0 to value of z. Whatever the value of z, it will uh, stay between 0 and z value. So output of z is less than 0, otherwise z. Okay, output is 0 if z value is 0, less than 0. Otherwise, the value of whatever the value of z, that is the result. Very popular in a deep learning, simple and efficient. Problem: dead ReLU neurons stuck at 0 if weight updated fails. Yeah. Then we have a leaky ReLU. Leaky ReLU. This is called a parametric ReLU. So here alpha into z if z is less than equal to 0. So fz equal to z if z is greater than 0. Okay. So alpha into z if z is less than equal to 0, and it's 1 if z is greater than 0. Okay. So fixed dead ReLU by allowing a small negative slope. So output range is minus infinity to the infinity. So basically we can use these things, ReLU, then 10H, and then sigmoid. These are mainly used, and these are not so important, but these are the topics, so we can discuss it. Then after that we have a softmax, combination of multiple sigmoid activation functions. Okay, so actually this is the last topic for today. Actually I have to go outside, and okay, so just we can discuss, and we can discuss a project in the next class, either tomorrow. Here, a hand-on simple neural network project. We are going to predict the stock price by using the neural network. Okay, so the last activation functions is softmax. This is a combination of multiple sigmoid activation functions. It calculates the relative probabilities. Let's suppose we have a 5 output value: 0, 0.8, 0, 0.9, 0, 0.7, 0.8, like this. Here we cannot use sigmoid as a sum of all probabilities is more than 1. So fzi, that is the value of these things. So e to power zi, summation of e zj, and the value of e is always fixed. So convert a vector of a number into a probabilities sum equal to 1. Useful for multiple class series. Let's suppose there will be 3 neurons in output layer. Output is 1.8, 0.9, and 0.68. Using softmax activation functions for each value: 0.58, 0.3, and 0.19. Okay, for each value. When we use softmax, this will give the 0.58, 0. So it's approx the same value. All right. So quick in sigmoid square value of 0, 1, good for probability. 10H square value of -1 to 1, allow the negative value. ReLU fast keep positive value. kill negative value, softmax give a probability distribution across the class. So these are the activations function we can use while we use our neural network programming. Okay. Okay. All right. So in the next class we are going to develop a project where we can predict a stock price by using the neural network. Either today night or in the morning I will share this. Okay. Okay. Okay then bye. Welcome.